Hello. In this video we are going to take a look at some more factoring. In this case we're going to have some multiple step factoring problems. So our first example, we've got x to the fourth minus 81. Now this one doesn't have the exact form of the special products that we looked at in a previous video, but it still is a difference of squares, because remember 4 is a power of 4 makes it a perfect square. 81 is a perfect square. And so we can factor this. We can write it as x squared squared minus 9 squared. And remember, difference of squares factors to the first one plus the second one times the first one minus the second one, or the square root if we're looking at the original problems. And x squared minus 9, that is a sum of squares. That one is not going to factor any further. That one is a prime. There's no factors of 9 that add to 0 if we're looking at this in terms of a trinomial. And so x squared plus 9 isn't going to factor anymore, but x squared minus 9 is still a difference of squares, because 9 is still a perfect square. X squared is a perfect square, so we can write that as the square root of the first one plus the square root of the second one, and the square root of the first one minus the square root of the second one. And so this one's going to factor to x squared plus 9 times x plus 3 times x minus 3. All right, this next one looks a little intimidating. We've got 6x to the fourth minus 5x cubed plus 48x minus 40. Now in that one, first thing we always look for when we're factoring is a greatest common factor. Between the 6 and the 5, there's no common factors between 6 and 5, so there's nothing on our coefficients. And with our x's, our last term doesn't have an x, and so we cannot factor this one with a GCF. But when we have 4 terms, we should always be thinking about factoring via grouping. And so let's group our first two together, factoring out the GCF. 6 and 5 have no common factors but x to the fourth and x cubed. We can pull out x cubed, and we're going to be left with 6x minus 5, 48x minus 40. Those have a GCF of 8, so let's factor out an 8, and we're going to be left with 48 divided by 8 is 6. We still got an x on the first term, and then 40 divided by 8 is 5, so minus 5. Again, to factor by grouping, these two have to be the same. If they're not the same, something's wrong. So let's factor out that greatest common factor now that we do have, 6x minus 5, and that leaves us with x cubed plus 8. 6x minus 5 is a linear term. That's x to the first power. We're not going to be able to factor that any further because there is no GCF. But x cubed plus 8, that is a sum of cubes. And remember, we can factor when we have a plus sign when they're perfect cubes using our SOAP formula. So if we have a cubed plus b cubed, that's always going to factor to a with the same sign, b. A squared opposite sign, AB, always positive, B squared, and so that's what we're going to use here. So 6x minus 5, don't forget any factors that you have from the first step are going to continue on down. X cubed plus 8 is the same thing as x cubed plus 2 cubed, so our A is x and our B is 2. Plugging into this formula, we get x plus 2, same sign, and then x squared, the opposite sign, a times b, so 2x plus our b squared, 2 squared is equal to 4. And then we have a quadratic here, x squared minus 2x plus 4. But if we look for factors of 1 times 4, or 4, that add to negative 2, we are not going to be able to find any. Anytime we use that SOAP formula, what we're going to be left with is going to be a prime trinomial, and so our factors are going to be 6x minus 5, x plus 2, and x squared minus 2x plus 4. All right, I'll see you guys next time.